uh, leading the Q developer community for Asia Pacific. And I just want to thank you once again for inviting us today, and really grateful for this partnership. And I really want to thank the gentleman who just presented right before me, emphasizing the importance of community, because that is what I want to talk about, community. Here, we at IBM really believe in the power of community, and that community will help advance the frontiers of quantum knowledge, skill, and technology. So I know Ken talked a little bit about this in the morning, but there's a lot of momentum gathered around quantum right now. And while at IBM, we are not about creating hype. That is the one thing we do not want to do. As Pat explained, the quantum journey is expected to be a very a sort of a long term. But at the same time, we know that there's been a lot of interest in this area, where a lot of tech companies are heavily invested in the R&D. Venture capital fundings has grown over 300 million. And we're seeing a lot of research number of papers climbing. And students from 1,500 schools have actually been using quantum computing via the cloud. And as you know, governments have been also announcing billion-dollar investments in this area. So while we learned from Pat that there's still a long way to go until we will actually see a universal fault-tolerant quantum system. So somewhere down the road in the future, we are hoping that quantum computing will help solve some of these real-life problems that our current classical computing system may not be able to solve for us. And in order to do so, while we are working hard to build the hardware stack, the software stack, we also know that building an ecosystem is equally important. And why is that? Now, as you know, quantum computing involves many branches of discipline, and each with very, requires deep knowledge. So quantum talent cannot be nurtured in a day. And that is why we think it's very important to partner with organizations to help nurture quantum talents. And needless to say, it takes time to really build in-house quantum capability. And we believe through an ecosystem, we can help achieve that. Now, as a big step, Pat mentioned this too in his presentation, but in 2016, IBM was basically the first to make our quantum system accessible to the world via the cloud for free. And through this initiative, instead of having the organizations and users to have to really strain to become this end-to-end quantum technology developer from hardware to all the way up to the applications, instead, by using the infrastructure that we provide, you can really focus on building quantum-specific algorithms or applications. Now, IBM has also provided the software stack to help you get started with that. Now, how many of you in this room has already used Qiskit? Okay, quite a few. Wonderful. So I'd also like to address the audience in the room who may be new to Qiskit, so please bear with me on this. But Qiskit is an open source software stack. And Qiskit is made up of elements that work together to help enable quantum computing. And the first element, Terra, is it basically imports and builds quantum circuits. It will optimize and compile circuits for backends and execute basically the circuits you built on our quantum hardware and simulators. Aqua is a high-level algorithm for applications such as machine learning, quantum chemistry, optimization. And the next element, Air, this is a high-performance simulator, and it is highly configurable. It provides a noise model to emulate real device performances. And the last element is coming soon. It's called Ignis, and it's going to be used for benchmarking and characterizing the quantum hardware, and to be used for quantum error correction, error mitigation. So you'll be actually learning about Qiskit, and you will actually get to install and have a hands-on experience after my presentation, and Raymond will walk you through that. But today I just want to take a little bit of your time to basically share with you how you can contribute to the quantum community. And there's many, many ways you could do that. So, okay. So first of all, for those of you who are still new to quantum or to IBM's Qiskit, rise yourself with Qiskit and some of the basic concepts of quantum. And you could definitely go through a lot of online resources to do this on your own. But what we found effective in our own community, or even within our own company, is actually by forming study groups. You can actually exchange a lot of information regarding what you're learning and get more in-depth knowledge and hands-on skills that way. Also, you can create your own tutorials based on what you're learning, and in your own world, in your own word and language as well. And I would strongly encourage you to write maybe what you're learning or the tutorials you are creating and share them in blogs or some kind of media so that other people could also benefit from what you're learning. At the same time, you can raise your profile in the quantum community that way. And also, you can, basically organize. Oh, actually, I'm also here to basically help you do this, but organize, for instance, on-campus events, workshops, symposiums on the quantum topics. And then lastly, another way is to contribute to the open source community, to the Qiskit community. Now, when I say familiarize yourself with Qiskit and some of the fundamental concepts of quantum, so as far as Qiskit is concerned, today is your lucky day, and tomorrow as well, and the day where you get to actually have a hands-on experience and with Terra, and maybe not hands-on exactly for Aqua, but you get to learn some basics on Aqua as well tomorrow. But also there are other avenues you can explore, especially if you are a beginner. There's what we call Q experience. I know Pat showed you the user interface for this, but it really looks like a music score here. And maybe I could show you the actual site. Okay, yeah. So yeah, so this is the actual quantum experience, what we call composer. So just like you're composing music, you can actually apply some quantum gates and see how that would basically change the state of a qubit. So here we have a 5-qubit simulator, each all in ground state, in 0 state. And just for the time's sake, I'm not going to try to compose an elaborate algorithm or anything here. But for instance, this is the poly X gate, which basically rotates your qubit for pi around the x-axis. So let me just put it right there. You just drag and drop this circuit. And so this poly X gate is also known to be called a bit flip. And by rotating pi around the x-axis, meaning the 0 state qubit will be flipped to a 1. So in order to do the actual simulation and read it out, we just need this measuring device set. And what you could do is just hit run, but this will take a little bit more time, so I'm just going to hit simulate right here. And right now it's running your quantum score. And you could see that the bit flip has been applied, and what initially was in the ground state is now in the excited state, the 1-to-1 state. Similarly, if I were to apply a Hadamard gate, which is a gate that we use to create superposition, and hit simulate. So now you see that we have about 46% of the qubits in the 1 state, and then 54 in the ground. So by average, you would think that the number of states will be equal in its probability, but this basic circuit is being run like 100 times. So just like if you're doing a free coin toss, even if you did 100 coin tosses, you won't always get exact 50-50 heads or tails. So that's what you're observing here right now. Okay, so just a brief overview of the Q experience. And this is a good, maybe a starting point for those who may feel like downloading the the Python code and start working with Jupyter Notebook may feel a little bit daunting to you, and for you to just start learning how some of the basic quantum gates operate. And actually, there's another fun application we have for you who wants to learn how quantum gate operates. This is called IBM Hello Quantum. It's actually a smartphone application. You can get this for free through the App Store. And I would be happy to run it on my own iPhone now, but because the screen is too small, I just created a video here for you to see. But basically, you can apply these different gates and see how that would change the state of the qubit. And you want to basically try to have a minimum, you want to apply the minimum steps to achieve the target quantum state there. So this is also a really fun way you can learn about basic concepts of quantum computing, and you could download it and start playing at any time. It's a fun way to also pass some time in the plane. And as if creating an iPhone app is not enough, we have also a board game called Entanglion, which was designed at IBM Research. A lot of the researchers at Yorktown love to have fun. And through this board game also, you can learn some fundamental concepts of quantum computing, such as qubits, superposition, entanglement, about measurement and error. So this is also the blueprint of this game, the board game, is available in GitHub. So you can actually download it and print it out and play it yourself. So this is about just a few avenues you can look into to familiarize yourself with IBM Q and quantum in general. Also, okay, I talked about study groups, and these are actual photos from the study groups we had in Japan. Raymond was also an active member in this effort, but it's really key to have, these kind of informal study groups where you could really come together with a common interest. And it's fine to have different, participants from all levels, and for beginners to also feel free to come. But it's key to include at least one technical leader in the group to have a sustainable study group, which is what we've learned. Also, I talked about, creating your own tutorials, write, share what you're learning in blogs. And this site called Kita is actually a knowledge sharing site for developers in Japan. It's a very popular site. So a lot of times when people are learning something new, using a specific programming language or building something, they go to this site and look for people who've already done it themselves. And so we actually have a pretty active user community for Qiskit already, and I've identified several enthusiastic community members who've been writing a lot of blogs on Qiskit. And just this past December, we had this thing called Quantum Computing Advent Calendar 2018. So during the month of December, every day we had someone from the community writing about quantum. So it can be on any topic. So sometimes it does talk about, how is the annealer quantum different from this type of quantum system. This person actually has written a tutorial on the Qiskit tutorial, meaning the person has sort of localized the tutorial content in his own words, maybe making it a little bit more easier to understand and adding his own discoveries along the way. So I just really encourage you don't have to be an expert to write blogs on quantum. You can be a beginner and you can write your own sort of endeavor in trying to understand quantum. And that would actually really benefit a lot of members who are trying to learn quantum computing. Okay. So on organizing events. So I just really look forward to working with you through this partnership. I think just having one tutorial session is not enough. There's a lot of things that as you start really using Qiskit, you probably have more questions, or you might want to have a different set of audience also involved in around developing interest around quantum. So I just really want to let you know that I'm here to basically support the collaboration, and so we can help help you sort of have a active community on site as well, not just online. And actually, these photos were taken also last year in Tokyo when we had a special event inviting students to our IBM research, and we had a whole quantum experience day with also some fun time playing with the Entanglion board game. So it was a great, exciting experience for also the Tokyo team. So lastly, about contributing to Qiskit. Now, I mentioned already Qiskit is an open source framework, and without contributions from the community members, we won't thrive. And for those who are still new or starting to use Qiskit, I know you need time to familiarize yourself with maybe the tutorials first, but once you start getting a little bit more experience, there's many ways you can contribute to Qiskit. And a good start is starting from actually reporting issues. And if you go to Qiskit, maybe I should just show you this site. Okay. Okay, so this is the Qiskit GitHub page. And if you go into one of the repositories here, and it talks about installation and some details, the different elements I just described. And then if you go further down, there's a section called Contribution Guidelines. Now, if you want to make a contribution, I strongly recommend that you first read these guidelines. Yeah. And if you're an old coder like myself who used to use a different version control system, and when introduced to GitHub, had to learn it the hard way by doing things that you're not supposed to, you definitely should first read the guidelines just to make sure you're making a contribution, but also in a way that is mindful of how things are organized within the GitHub repositories. And actually, there are a lot of online tutorials on GitHub itself and how to create your repository, how to clone it, how to pull requests, make branches. And so definitely refer to those when you actually start, before you start contributing to Qiskit. And lastly, I want to actually share with you an upcoming event. We are having the first off-site Qiskit developers event in late February, and it is called QCamp. And this is a 3 days of having Qiskit tutorials, some technical deep dive conversations, and a hackathon at a ski resort in Vermont. So if you get tired of using, doing with the coding, you can actually also enjoy skiing or going to the spa as well. But I must say though, this is an invitation-only event, and we have only limited seats. And I checked with the person who's leading this program, and we still have few availability. So I think I should talk to Dr. Chang, and maybe if you could help identify some candidates who we could nominate. Those who are nominated, it doesn't mean that you can definitely go. First of all, the dates are coming up, and for someone to commit to be in New York and in Vermont around this time, you need to check your schedule, obviously. But the transportation, accommodation, and food within the United States is basically covered. You have to just get yourself to New York and fly out. That part is on the participants. But once you enter the country, from within the country, that part is covered. That's what I heard. Okay. Okay, so I just wanted to emphasize the importance of community. And I know this is a really exciting beginning for us. And as you start this journey, I know there will be a lot of collaboration going on, both on online and offline. So I just want to really tell you how much I'm looking forward to collaborating with you. Thank you.